So the next thing for us to look at is how radicals and exponents are the same. So x to the 2/3 power is the same thing as the cube root of x squared, which is normally the way that I would write this. Or if it helps me in a simplification process, this is like the cube root of x, and then square that. This would not be the simplified answer. This would be. So 8 to the 1/3 power. Notice the 3 is the denominator. So the 3 is the root. Like the roots grow underground, and this is like ground level. So the 3 is in the denominator, which means it's a cube root of 8. And then the cube root of 8 is 2, because 2 to the 3rd power equals 8. So keep in mind that the denominator of the fraction, again, kind of like growing below the ground, roots grow below the ground, that's the root on my radical. So if I'm looking at this and I want to simplify it as much as I can, it says rewrite it in an exponential form. Well, I know that that means to take this 10x to the 12th power, and with the 4 being the root, that's the denominator of my fraction, so it's to the 1/4 power. And then basically it's saying simplify it if you can. Well, 10 to the 1/4 power I can't simplify, so it's just 10 to the 1/4 power. But this, think about that power to a power, I multiply the exponents. 12 times 1/4 is 3, so this becomes x to the 3rd power. Again, this means to take the 10r to the 1/5 power, but then I have to raise that to the 6th power. Well, this ends up being 10r, a power to a power, I multiply the exponents. 1/5 times 6 is 6/5. And then that one I can't reduce at all because I can't take the 5th root of 10 or the 5th root of r without knowing what r is. Looking at this, my 16n is raised to some power. The 4 is the root. The 3 is the exponent on top, so 16n to the 3/4 power. Now I can take the 4th root of 16 because the 4th root of 16 is 2. So this is like 2 cubed and then n to the 3/4 power. I can't simplify that. 2 cubed is 8, n to the 3/4 power. I also could have cubed the 16 and then taken the 4th root, but usually it's easier to take the root first. This just means m to the 1/2 power, because a square root, it's like there's a 2 there, we just don't write it. Well, this is already in exponential form. I want to rewrite it in radical form. The first thing I want to do is think about 1.25 is really 5/4. So when I write this, the 4 is the root. I'm taking the 4th root of 2v, and then I'm raising that 2v to the 5th power. I can raise 2v to the 5th power, but hang on just a second. Think about what this really does. This is like the 4th root of 2v times another 2v times another 2v times another 2v and finally another 2v. So I have 4 of the same thing underneath here. Well, the 4th root of 2v to the 4th power is just 2v. That comes out from under the radical. Times what's left after I do that is a 2v left under the radical that I can't simplify. Now I put this dot between these because otherwise if you scoop these too far together it's going to look like this is a v to the 4th maybe in a square root. So 2v times the 4th root of 2v. Again here it's a cube root of 125b squared. And sometimes I look at it this way. Here's why I'm going to look at it a little bit differently. I'm going to look at it as the cube root of 125b, and and then I'm going to square, because I'm thinking ahead. Here, I recognized that I could take the fourth root of part of this thing that's raised to the fifth power. Here, I could square the 125 first, but I noticed that 125 is a perfect cube. So I'm going to do the cube root first. The cube root of 125 is 5, and then I'm left with this cube root of b that I can't simplify, and this whole thing is squared. So I have 25 times the cube root of b squared. X to the 3/2 power, the square root of x cubed. Remember, this is like the square root of x squared, which is a perfect square, times the square root of a leftover x that I can't do anything with. So I end up with x, square root of x squared is just x, times the square root of x. That's as simplified as I can get that. Here, this is the cube root of x to the 5th. Well, that's like the cube root of x cubed, which is a perfect cube. And then what's left over is an x squared. So I end up with x, which is the cube root of x cubed, times the cube root of x squared. It's going to take some getting used to. You're going to have to practice this. And as you run into questions, make sure that you ask me.